Hello, my name is Musaddiq Momin. Today, I am going to explain one problem that how to solve for base shear in case of earthquake. Let's see what is example. In this, four-storied squared RCC framed building is shown in figure. We will see figure in next. With a live load intensity is given as 4 kN per meter square. Is to be constructed in Pune region. Work out seismic forces on earth on structure by IS 8 by IS 1893. All beams and column sizes are given as 300 by 300 mm. Slab thickness is given as 120 mm. Wall thickness is given as 150 mm. Considering brick density as 19 kN per meter cube, height of each floor is given as 3 meter. Here, four-storied squared RCC frame structure is given. This is a figure. We can see that plan dimensions are given as 32 by 32 meter, and height of each story, it is 4 story, nothing but G plus 3 building. Height of each floor is given as 3 meter. Let's see how to solve this problem. In this, we have to write a given data as number of stories are 4, that means G plus 3 building. Live load intensity is given as 4 kN per meter square. Region is given as Pune. Beam size is given as 300 by 300 mm. Column size remains same. Slab thickness is given as 120 mm. Brick density 19 kN per meter cube. Height of each floor is 3 meter. Wall thickness is 150 mm. As well as we have to consider concrete density as 25 kN per meter cube. Let's assume if data is not given. If we see a 4-storied building, that means there should not be a residential building in case if we see a plan dimensions. Here, infill walls are absent. Public building having a 4-storied because G plus 3 construction is given. Using OMRF, we will see that what is OMRF, how to calculate, how value should be determined with respect to that. Soil strata is not given, so we have to consider hard soil strata. Region is Pune, so a Pune region will lie in zone 3, maybe in zone 4. Here I am considering Pune region lie in zone 3. It will depend upon this map. In IS 1893, different types of zones are given according to region wise. So Pune region will lie according to zones. Let's see. Solution. Step number 1 is calculation of AH, that means horizontal seismic. For that, formula is given as Z by 2 SA by G I by R. For calculation of Z, we have to go page number 10 in IS 1893. Let's see. This is page number 10. So, according to zone number 3, if I consider zone number 3, then zone factor is taken as 0.16. So, I have taken here 0.16. Let's see next step, calculation of I. In page number 19, it is given as, let's see first of all page number 19. This is page number 19, and we are going to use I as, let's see, here different types of structures are given and we have to choose If there is a public building, for example, hospitals, buildings, schools, different different buildings, like having a emergency buildings like hospital that I said, for that a value of I is to be considered as 1.5. According to that, if residential or commercial building is given, then value of I is to be considered as 1.5, 1.2. For other buildings, it is considered as 1. So we are taking I is equal to 1.5. For calculation of R, we are going on page number 20. Let's see on page number 20 for calculation of R. For calculation of R, we are considering OMRF system. So that for OMRF, value of R is taken as 3. If there is SMRF, then it will be 5 for R. Then next, for steel buildings with ordinary moment resisting with OMRF frame, according to that, value should be taken. So that we are choosing our building is RC building and we are using OMRF. So value of R is to be taken out 3. Then next, calculation of TA. For calculation of SA by G, we need to find first of all TA. So calculation of TA according to page number 21. Let's see first of all page number 21. This is page number 21. And here value of TA is given as calculation of TA is to be done in 3 categories. In that, for RC MRF building, we are using this formula. For RC steel composite MRF building, we are using this formula. And for this formula, it will be useful for steel MRF building. In according to given condition, there is a RC building and we are using MRF type. So that formula will be chosen as 0.075 times h raised to 0.75. Here h is a total height of building. So according to that, we have to take value of h. In our plan, our total height of building is 12 meter. So we have taken a value of h as 12 meter. And according to that, T value is to be calculated out. For SA by G, according to page number 9. First of all, let's see what is page number 9. This is page number 9. And for calculation of SA by G, we are using hard soil condition. And in this section, we just have to check for hard soil condition. Our TA is 0.49. So according to 0.49, we get a second condition. In that, T lies between 0.4 to 0.4 second to 4 second. So our formula will be 1 by T. So SA by G will be equal to 1 by T. So we are just reciprocaling of this. And according to that, after getting all these values, we have to use a formula for AH. Putting all these values, we will get AH. That means horizontal seismic coefficient. This is step number 1. Let's see what is step number 2. In step number 2, we are calculating let's see next step, that is step number 2. In step number 2, we are calculating seismic weight. In seismic weight, we have categorized as W1 and W2. W1 for roof and W1 for roof floor and W2 will be for other floors. We are considering one load for other floor. So that first of all, we will calculate slab. weight of slab. Weight of slab is nothing but the volume of slab into density of slab. Slab is generally made up of concrete. So that this 25 indicates the density of concrete. This 32 into 32 into 0.12 is a volume. If we see our plan, in that 32 meter by 32 meter is a plan and 0.12 is the thickness of slab. So that after multiplying density, we will get a weight of slab in kilonewton. For calculation of beam weight, we are considering x direction and y direction separately. In that, if we consider this 30 length, width, depth as well as density and number of beams available in along x direction, so that we will easily calculate out. So that this 32 will indicate length of beam. This 0.3 is nothing but the width of beam according to given condition. This depth will be calculated as 0.3 is a depth, my overall depth, minus 0.12 is a slab thickness, into this 5. This 5 along x direction nothing but the beam number 1, 2, 3, 4 and 5. So that we have considered 5 here and 25 is a density. So W is to be calculated out for beam. And column, if we are considering roof, so that weight is to be calculated at as these are given dimensions into, for roof we are considering only half height. Here we are considering only half height for roof, 3 by 2. So that 3 by 2 minus this 0.3. Here 0.3 is a beam depth, because this depth is to be subtracted because we have already calculated weight of beam. In that, this depth is to be considered. Here, similarly, y direction calculations are to be done in beam. I forgot to tell that. Next, for column, here length, width, height into number of columns. Let's see how many number of columns. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 into 5, 25. So here 25 number of columns. Then next, this 25 indicates the density of concrete. Next, column for other floor is to be calculated out. Same process is to be done, but instead of 3 by 2, only 3 is to be taken. That means full height is to be taken, because in that, if we are considering this floor, half of this and half of this will add as 3. So calculations will be similar, but instead of 3 by 2, here 3 is only 3 is taken out. For then next, for calculation of walls for roof, similarly this 32 will indicate overall length minus this 0.3 will indicate our column dimensions are 0.3 by 0.3. So in that, this 0.3 will be divided into half and this 0.3 will be divided into half. This 0.3 by 2 and this 0.3 will be subtracted. This 0.3 by 2 and 0.3 by 2 will be subtracted, and next calculation is to be done, so that overall 0.3 is to be taken out. This will be length. For width, this 0.15 is given the thickness of wall, and next 3 by 2. Similarly, as we have done for column for roof, similarly walls for roof is to be taken out 3 by 2 minus this 0.3 is beam depth, and this 2 will indicate walls for a roof. Let's see, infill walls are absent. That means entirely, if we see entire structure, in that only for if we consider only roof in x direction, there are only two walls, here one and here two along x direction. Similarly will be along y direction, one and two, so that overall calculation will remain same in along x direction, along y direction also. Let's see next step. In that, walls for other floor will be calculated similarly, but this height is to be taken as full. That means half of upper slab minus half of lower slab. I mean floor. Half half of upper floor minus plus half of lower floor. This will lead to calculation finding out calculation of walls for other floor. Next, live load intensity is given as 4 kilonewton per meter square into 32 into 32. These are plan dimensions. Let's see what is this 0.5. This 0.5 indicate that 50% we have to take overall intensity. If our live load is up to 3 kilonewton, then we have to take 25%. If our live load intensity is more than 3 kilonewton, then we have to take as a 50%. 50 divided by 100 will be equal to 0.5. So we have multiplied by 0.5 here. Now let's see, W1 we have considered as weight for roof, so that A plus B plus C plus E. Let's see, whatever we have found out here, on roof, slab will be weight of slab will be considered, weight of beam will be considered, weight column for roof will be considered, and column wall for roof will be considered, so that addition is to be taken out in such a way that this whole will be add. In that, W2 will be calculated, that means weight for other floor, so that in that A plus B plus D plus F plus live load. Let's see A for other floor, slab load, weight of slab will be considered, beam will be considered, this column for other floor will be considered, and otherwise other will be considered as this walls for other floor, and live load intensity is considered. This W1 and W2 is to be calculated up. Then overall weight will be calculated as W1, that means our roof is 1, so W1, and how many other floors are there? Let's see. For calculation of 3 times W2, we will take as this W1 will be at this W1 will be related to floor, W2 for second floor, W2 for third. I mean, according to W1 will be related to floor roof. W2 will be related to this third floor. This will for second. This will for first. That means first, second, and three. For these three floors, W2 will be considered out, and W2 into multiply by 3 will be taken out. So that I have multiplied by 3 here. Let's see. In that, after calculation of this overall weight, we have to go for next step, that is calculation of base shear. Here VB is equal to AH into W. This AH we have calculated in step number 1, and into W this we have calculated just now, and VB is to be calculated out. Let's see next step. We have to make one table in that story number WI, that means corresponding weight, height, multiplication of these two and square of this QI and VB. QI will be calculated as VB into WI square divided by WJ. For story number 4, we are considering W1 because it is a roof. So W1 value will be put out here. This value is W2, W2, W2. Height of each floor accordingly. This is height of 4th floor, that means 12 meter, 9 meter, 6 meter and 3 meter for first story. Multiplication of these two into HI square will be calculated as WI HI square, and summation is to be taken out. QI will be calculated as VB into corresponding VB, just now we have calculated here VB. Next, WIHI corresponding WIHI square divided by WJHJ, that means sum. This value will be put out here, and accordingly values are to be taken out. For calculation of base shear, we have to take cumulative addition. First of all, this value is to be taken out here, then cumulative addition is to be done out. This value will exactly match with our VB, so that it is checked out crossly simultaneously. In next, we have to just draw this diagram. As previously we have drawn this diagram, just corresponding value of QIs are to be put out, and this step is to be drawn out. Hope everything is clear now. Thank you.